Okay, here comes problem 50 on page 657. I think you've got a sister. Yeah, it's 51. Right next to it. Now this should come out pretty smooth because I've already done this problem twice. You know, along with these videos, I ought to make a making of the videos. I could have kind of a blooper reel. I just did it. I just ran right through it with a 0 here instead of a 5. And boy, you get root 7s all over the place. It's not a pretty thing. So let me do it the right way here. Should work out a little bit better. So first and foremost, this says, here's an equation. Trust me, it's an ellipse. You don't really have to trust me. You just have to look right there. You have to see that it's quadratic in x and y and see the plus. You've got an ellipse in most situations. We're going to talk about that more. So turn this into something you recognize, find the center of the focal points, the vertices, and graph the darn thing. So what does that say? That says turn this form into a form that looks like this. Plus y minus k squared all over b squared is equal to 1. Okay, and then if you do, there's the center HK, there's the semi-major diameter A, there's the semi-minor diameter B. Now actually, this problem gives me a good chance to point out to you that the way that you're being taught, there's kind of a subtlety here that maybe you haven't seen yet, and that is that sure enough, that A is the semi-major diameter. It's the longer one. Semi-minor diameter is B. The thing is, it may not be along the x direction or parallel to the x direction. I have written a form right now that is appropriate for a football on its side, right? Where the semi-major axis is parallel to the x-axis. If the football is standing up, then you really need to switch the A's underneath the Y's, the B's underneath the X's. And then you're always going to be able to say, if you do that switch, that A is the semi-major axis, B is the semi-minor axis. But you can't, I'm going to say you can't necessarily tell at the outset. I'm going to just tell you that that's not true. You can. But if indeed it turns out as you're working this, as this problem will, you need to make the switch, and I'll show you why. But first, let me go back to what I just said. I can tell that this is going to be a football standing on its side, and I can tell by looking at these two coefficients, the one on the x and the one on the y. And I'll tell you why. I'm not going to write it down. Do I have enough space to write it down somewhere? Yeah. I could rewrite this right now because I have a 4 up in, I know there's no fraction here, but if I consider this 4x squared all over 1, I've got a fraction, and I could rewrite 4x squared as equal to x squared all over 1/4. Yeah? And I could rewrite 3y squared as equal to y squared all over 1/3. Okay, and if I do that, this 1/3 is a bigger number than 1/4. And it's under the y squared. That's telling me right now, you have to kind of work through this whole thing to see how that works out. That's telling me that the major axis is underneath the y squared, and this is a football standing up. Okay, let me stop talking and let me start doing this. What are we going to do? What are we going to do? We're going to complete the square. Okay, I'm starting to get silly. I've done that so many times. So what do? So let's do a highly technical. You have to be trained to do the following. I'm going to put the 8x over here close to the 4x. And I'm going to put the 3y squared close to the y equals 5. Don't do this at home. Okay, so I did that so that I can complete the square. I'm going to take 4 out of everybody here. Oh, by the way, you really don't have to do this. You could complete the square if you want to with a non-unitary coefficient on x squared and y squared without the coefficients being 1. You just don't add and subtract the same thing as you do here. So To me, this adds a simplification. It also adds a slight complication. I'll point that complication out in a second. I may stop doing it like that. Let's just see. The more I think about it, I might stop doing it like that. So I'm going to complete this. I've got two non-perfect squares here. I'm going to make them perfect inside the parentheses, okay? So working inside the parentheses, if I want to complete the square here, divide the 2 by 2, you get 1. Square it, you get 1. Add it, subtract it, okay? I just added 0. Let's not talk about it anymore. Same thing over here, inside the parentheses, divide the 2 by 2, you get 1. We get minus 1 actually. Square it one way or the other, you get 1. Add it, subtract it. And you now are close to having finished completing the square. You're going to recognize this thing right here, x squared plus 2x plus 1, as x plus 1 squared. There's your minus 1. You're going to recognize this guy as y minus 1. I need another parent, y minus 1 squared. There's your minus 1, still equals 5. And now here's the complication. In fact, you didn't really add minus 1, you added minus 4. Right? You didn't really add 1 and minus 1, you added 4 and minus 4. So let's not forget that. And this step, when we're distributing the 4 over everybody, and you get 4, x plus 1 squared, I'm multiplying that times that. Now I'm going to multiply the 4 times the minus 1. And I'm going to do the same thing over here. The 3 multiplies this term, and then the 3 multiplies this, and you get 5 over there. Okay, so I'm pretty close now. I've got 4x plus 1 squared plus 3y minus 1 squared. I've got 7 hanging over here. I'm going to put it over there, add it to 5. I'm going to get 12. That's nice that I have 12. But I've got to have a 1 here. So I'm now going to divide every term. What? That term, that term, and that term? Yeah, by 12. So when I divide 4 by 12, I get 1/3. And that's going to turn this into x plus 1 squared all over 3. That's worrying me a little bit, but I'm going to just move on. I'm going to write that root 3 squared. I've got y minus 1 squared all over 2 squared. 3 divided by 12 is a 4 down below, and a 4 is a 2 squared equals 1. There, I did it. This guy, I really wish I had written that in a different color, and watch me, I'm gonna. This guy is x plus 1 squared all over, what did I say? Root 3 squared. And this one is y minus 1 squared all over 2 squared. This is 1. Check it out. Same thing. It's the right form. But now let me do some deductions here. I deduce that a is the bigger of these two numbers. And 2 is bigger than root 3. Root 3 is like 1.7. So a is equal to 2 and b is equal to root 3. Aha! I got to go up here to the top because the major axis is the larger of these two, and I'm going to call it A. I'm going to show you why in a second. So I got to go back up to the top. I don't have to change this. This is fine, but I got to change this to A squared and this B squared. I tried to warn you. I told you that based on the 3 and the 4, the one with the smaller number as a coefficient is the one that has the major axis. And you can kind of see why now, and it's because when I divided through by 12, I ended up with a bigger number here than I did here, because that went down in the basement. Now, enough. So here's A and B. What have I got here? Let's put in some numbers. I have got a center, and that center is minus 1, 1, yeah? Because h is minus 1, and k is 1. If x minus h is x plus 1, h is minus 1. If y minus k is y minus 1, k is 1. So maybe I ought to write that where it was asked for. Okay. And now, where are the vertices? There is no way I'm going to jam the vertices into that little area and draw a graph. This just is not going to happen. This is just not going to happen. Let me calculate the vertices over here. Okay, I better draw a graph before I do so. Let me draw a graph. It's going to be a small little football, but I think we need it just to get ourselves grounded here. So it looks like that. This direction is B. This is B right here. Boom. B. This is A right here. Boom. A. Okay, so that means that this point has the same y coordinate as the center, which is 1, but it's removed plus and minus b from the x coordinate. So these, where do I write the focal points? So the focal points down here, these two guys are 1 and b root 3, what is this, minus 1 plus and minus root 3, right? It's not easy to see. 1. There's the x vertices, if you will. Here come the y vertices. They have the same x coordinate as the center, but they are removed plus or minus 2 from 1. So they're going to, well, I'm just going to write it that same way, 1 plus or minus 2. So you're going to get 3 and you're going to get minus 1 as these vertices right here. So I got the vertices and the center taken care of. Here's why you did the machinations to line up the A's and B's. Because I'm going to draw this same little triangle right here. There's C. There's the line from here to here. Here's this little triangle. Okay, I'm going to put a dotted line around him and I'm going to draw him over here. Okay, here's the little triangle. And it's the same triangle that we're always used to. It's got C on that side, it's got A on this side, because this distance plus this distance is 2A, and they're the same thing. And then this is B, which is the semi-minor axis. So if you do these machinations, you will always end up, meaning for both orientations, football up, football on its side, you'll always end up with A squared equal to B squared plus C squared, right? So if you put these numbers in, you've got 2 squared is 4, minus B is root 3 squared is 3, take the square root, you got C is equal to plus or minus 1. If you will, there's a focal point 1 above the center, there's a focal point 1 below, and so the foci are same y coordinates. Here's the vertices here. Here comes the foci. I bet that's off the page. I'm going to move the page. So it's got the same y coordinate, but it is minus 1 plus or minus 1 right there. So it's minus 2 and it's 0 for the x coordinates. Okay, let me just check something real quick. Yeah, I don't think you can see that, so why don't you look at that.